Right. So tutorials. Where did we get to? So we went
state channels, and if you scroll down to factory.
Okay.
So that exercise, it started with, it is inconvenient to manually replace counter values each time I check it. Instead, I should have a method for that. And what we basically did as the exercise, whether we interpreted it right, I'm not sure, but we basically wrote a Rholang loop to increase a counter. And I think this is where we're up to. So if you start reading from here, hopefully it will fit in with what I've just said.
Somebody's making noise. Is that me?
Sure.
It's Bill.
Okay.
Is that better?
Yeah. The problem is that many projects may want to use counters, and having just one is sufficient. The solution is to make a factory contract that makes counters. When the factory contract is called, it sends back a brand new counter. How would a user call the factory to get the new counter? Huh.
That's interesting. I guess I never went this far in the tutorial. You know, I mean, that's, oh, I probably have, but I didn't realize. I mean, that's a standard pattern in object-oriented systems is a factory. So people who know about
Objects, yeah.
objects would understand what a factory is. So I want to make a new factory. So I call the counter factory to give me
Counter
a factory. And then a factory has some behavior, which is, probably going to, modeling something being constructed. Well, no, something being, a counter object. I create if I want a counter object, I call the factory to get it. Because counter isn't one of the built-in types. So I can't just say new factory because, well, that's going to make a name. It's not going to make a factory.
Yeah.
So the answer that's marked counter factory, bang, my increase, my reset. You're sending on the counter factory channel presumably the amount you want to increase and something to do with a reset flag of false or true. But essentially in OO that would instance an object via the constructor, right? What does it do here? It sends, so I get that it's sending information to the channel, but that information must somehow be an instance of an object in a semantic sense. Am I right? And I don't know.
Yeah, it's like that. I mean, we're just sending, we're incrementing old by one. We're adding one to it, and we're sending that to the counter, the current counter. Okay, we read the old value, add one to it, and send back the new or the old.
Right. So when this gets executed, that means that this finishes basically, and it's
Well,
increment.
that means somebody called increase. Somebody sent one argument to increase.
Yeah. Well, that's counterfactory sends something to
Oh,
increase.
no.
So I will admit that this confuses me a little as well here. Inside counterfactory, we're creating two contracts, an increase and a reset.
Yeah.
When increase gets called, it increments it by 1. When reset gets called, it turns it back to 0. What is confusing to me is the binding between my increase and my reset to increase and reset.
Yeah. In other words,
That confuses me.
it confuses you.
Yes.
Well, where do we get the increase and reset? Well, those are new names that were made by the person who's calling us. The person who wants to counter wants the capability to increase it and reset it.
Right.
So, when I pass a value, when I do a new, let's say, what's a good counter? Name. I do it. Scroll down to the test program. Where are we? Oh, we heard this. Demo using the counter here is what we're supposed to do. So, so we have to write that part, right? Demo using the counter here.
Right.
How would we write that? Hello.
Well, I mean, the obvious answer here is that counterfactory takes two arguments. So we need to call it with two arguments, right?
Yeah. But what would we do for the reset?
So what I don't understand is how would I now increase my counter after I get my counter back? So I can call counterfactory.
Yeah, call counter. Okay, so send my increase and my reset to counterfactory. You know, what are you doing?
He's copying and putting it into the development environment.
Yeah.
Oh.
That's. Was it here or the? Yeah, it was here. Can you guys see all right?
Yeah, it's there. It is.
I could use 1+ on the font.
All right, and here.
So where it says nil there, line 29.
Yeah.
You want to send counterfactory my increase and my reset. Capital I.
I saw.
It's counterfactory should be capital F, right? I can't see.
Yeah, should have been. Yeah.
What was that? Oh,
You're missing an N on line 1.
So, uh, um, um, let me get something. So you can't send a name as an argument to a contract.
right, we have to make it a process.
Okay.
Okay, and then, so we're saying, what we're really saying is create a factory.
No, we're saying create a counter.
I'm sorry, yeah, good. Create a counter and give me the increased capability in my increase in the on the my increased channel, and send my reset capability to the my reset channel.
I like that way of putting it, Jim, because I think you're right. I mean, what we're essentially implementing is instantiation in OO terminology, but in Rholang terminology, what we're doing is what you just said.
So the
And-
call to counter factory, or counter factory bang, actually binds the contracts that are defined inside of counter factory to the names that I have supplied.
Right. That's the way arguments are normally passed to routines.
Indeed.
So
it's worth-
line eight defines a name called increase. And
Right.
that name gets bound to the process that I send it in line 2 as increase.
Well, sort of, but it's, the name is really this huge unforgeable name. We just call it increase here locally. We could have called it, right. I mean, it doesn't matter what we call it, but.
Right, but my point being that I don't need to return the contract increase and the contract reset. They're automatically bound as a result of line 2 being coded the way that it is.
Oh, no, we're sending it on on those channels. We're sending the increase on the channel called increase. We're sending the reset function on the name supplied to the second argument. So we're, in order for them to get the value, they have to read it. So we need a for statement that reads them.
I thought we sent processes as arguments rather than names. I mean, I think that should be towards the bottom, where we did, my increase and my reset. Like, these are processes and not names.
Well, on 27, they're names.
Right.
On 29, they're processes.
Yeah, I get that. Well, maybe, perhaps I think why this is a little confusing is I'm trying to understand it using knowledge from other programming languages. It's
That's a big mistake.
yeah, it is actually, because if this were to be most other programming languages, it wouldn't just work this way.
No, of course not.
So let me ask this question. The contract definition on line 17, does that new contract get bound to the name my reset?
Well, the unforgeable name that we call reset is sent to the is used as the channel to which we send a reset capability.
Yeah, I think I get you, Jim. I mean, that reset name itself on line 17 is internal to the execution of the counterfactory code, which is scoped.
Right. It's not right. It's an argument passed to this call to the so the user supplied a name, an unforgeable name, okay, which then gets defined to reset the counter.
Okay, so yes, so when I send my reset to counterfactory, my reset is an unforgeable name, and it gets defined as the channel reset on line 17. That unforgeable name becomes the channel that's defined on 17. Is that correct?
Okay, yeah. So let's write a for statement and read the increase and the reset capabilities.
Yeah.
So on line 30, you want to add a for statement to read those two values. Inside the brace.
For
You want a parentheses.
what's the
My counter, my increase. Oh, is it just increase? Just call it INC. INC equals, yeah, in from my increase. And you need a semicolon. You want to join it with the input of reset. So inside the parentheses, put a semicolon.
oh, okay, it's a join.
Join, right? And reset equals my reset, or in from is read from my reset. Okay, so now we have those capabilities that for the counter. So now, so we want to call increase, or do we want to call reset first, or doesn't it matter? I can't. I'm not looking at code here. I'm on my phone. So
Star increase.
Let's try.
no, increases is the name. What result? Oh, you want to print it out?
Yeah.
I wanted to increase the counter a few times, and then print out the result.
Okay, so this is this creates the counter, and we need to okay.
So we want to increase, right? We want to increase the counter. So we're gonna send act and increase.
Like that.
Right. And you could do it a few more times. Now, if we don't wait for the act, so now we have to join two act reads in the for statement. So in parallel, where does, no, you still, okay, I guess it doesn't matter. So you have to read two acts. Oh, wait a second. It's not, so you want to join two acts. But you want to get, that's interesting.
On line 31 and 32, why do we have to, why are we sending acknowledgement twice on increase?
Well, we're counting something.
Oh, okay.
So you know, if we have two things, we're going to call increase twice. And actually, the act isn't what we want. We want to get we want to get the return value to the increase is the old value, right? Yeah. So instead of act, we want we want to create names for them, X, Y, or A, B. So you up on your new statement on 27, add X, Y. Okay, and then in the increase statement, you return X in the first one, and return Y on the second one. What are you doing? It only takes one argument. Instead of act, instead of act, we want to put X. That's the value returned. And
the other one.
Right. Okay, and then our fourth statement, we want to do a join. Instead of act, we want X. What are you doing?
Bug.
And then we want to join that with B in from Y. Okay, and then we want to print out, send to result A and B. Could make it a map or a list or a tuple, whatever.
So this is a list. Explore. It's empty. Oh.
Where did X and Y, we sent the empty process, right?
That's interesting. Oh, you know why?
Oh, because
somehow we're not resolving it. We're getting a name when we should be getting a value. It doesn't print them out because they're unforgeable names. If we put them to standard out, we would see that. But
Oh, you need, yeah.
okay, but how could they be unforgeable name? Okay, let's look at the increase function. We don't set it as standard out. I mean, we could. What are we doing?
Looking at the increase function.
It's the ACK channel that receives.
Okay, it returns old. Current count. It reads old.
Current count. This is counting. This is just counting until.
Right. But what we send to the ACK channel is the old value, right? It's an integer. We think it's supposed to be, but I don't think we initialize it, do we? Where do we?
Line 5.
Current count is 0. So this can accept an empty value, and it would still count.
Yes,
What do
if
you
you
mean?
put in nil for ACK, it would still increase the count, yes.
Yeah.
Right. It would send to the channel nil.
But it's the ACK channel is what's receiving the value, right?
Yes, the
Right.
old value, yes.
So,
And
so
what-
if we scroll down, I don't see how X and Y or increase are related to ACK, which is storing the value.
Well, we're for ACK, we're passing a X and Y. So ACK is X on line 31, and X is
Ah,
ACK is Y on line 32. So we're passing different.
I think I see. Can you scroll back up, please, Carol?
To where? To
To the increased contract, and well, right to the top actually. Right, so. But increase. Oh, but the parameters passed to counterfactory are my increase and my reset, right?
Yeah.
And yet the parameter passed to the increase contract is ACK, which is the X or the Y.
It's a dummy. ACK is a dummy parameter. It's never declared. What do you mean? I mean, we declare it down there, but we don't use it.
Oh, I see.
What we pass for ACK is not, it's just a dummy variable name. It's actually going to be my. It's actually going to be.
Yeah, I'm with you, because you've got to unpack the syntax contract increase of ACK, which is actually for read into ACK the value of increase, which is the my increase that you passed in.
My interest is ACK. Okay.
Yeah.
So I send to my increase the old value. Which the first time in is going to be 0 is the old value. And we add 1 to it. But we're not printing out. We're not printing out the old value plus 1. We're just printing out the old value, which is fine. As long as we know the counting starts with 0. First time we count, it's going to be 0.
yeah.
So normal debugging here would be to see how far it gets, to see what line it dies on. Scroll down.
How do we do that?
Okay. So
Typically debugging includes putting out a message as the first line in every for comprehension.
Okay, so result.
And you would put out old here, yeah. And print out the value of old.
well, all's going to be an integer. Does it? It doesn't support concatenation within integers.
It doesn't.
So,
But if you output a list with the second item being old, you'll see the value.
right.
And that will confirm when you see increase bang old, that will confirm that that for actually worked.
No, it doesn't.
Well, then that for did not work.
So did we call? Yeah, but okay. So
yeah, this works. So this gets executed.
Yes. But the call to increase or on line 8 or the invocation of the for on line 9, one of those is not working.
Let me see. So this gets executed.
Right, so counterfactory is actually being called.
Yeah.
So now on after line 31, because that's a for, the first line output, yeah. And that tells you that that for comprehension actually ran. You're missing a part.
Oh, thank you. No.
So what that means is that line 31 did not work.
Increase, my increase. So once they get created,
I'm actually wondering whether or not you need line 31. So that if you were to comment line 31, and then line 33 and 34 do my increase instead of increase.
you're right. I don't know what I was thinking. Wait, we don't send anything to those channels up above.
No, we do, Jim. This is why I was asking you about the bindings. So when we send to counterfactory, my increase and my reset, if we go back to the the counterfactory contract, please. Scroll up just a little more. what it's saying is that on line 8, the contract increase gets bound to whatever you provided as the increase argument to counterfactory.
Yep, I wasn't thinking.
Okay, so this is why I was asking about the bindings. This is a little, it's a little confusing and perhaps counterintuitive. But
Well,
what it says specifically is that increase and reset receive the values of the contracts that I define inside of counterfactory. That is what that says.
yeah, it basically says I'm going to do a persistent read of that channel
Right,
with this continuation.
right.
Which channel?
Whatever
The
channel you passed to counterfactory.
Yeah. So what confused me is very often I'll write a thing where I'll return a set of capabilities.
Right. In Argo, typically that's how we do it. Yes.
Right. And we basically make the new capabilities inside the factory. But here we're saying these names you already made, we're just going to use them. We're going to define what they do. You know, we're going to give them behavior.
We're gonna do a persistent read on that.
Yeah, right.
So to explain what Jim and I are discussing right now, let's add a line between 7 and 8. And let's do a persistent read inside of a for comprehension. Does everybody know what a persistent read is?
Yeah, I know.
Okay, so for and right. So let's just make up a name here. And we're going to persistent read increase. That is not a persistent read. That's a single read.
Oh yeah.
I think that's a persistent peak, but okay. Anyway, yes, the equals is correct. So what this is saying is read forever from the channel increase that was sent to me. That is what that says. That is identical to the functionality provided in line 9.
Why identical?
A contract is nothing more than a persistent read on the channel defined by the contract name.
Yeah.
So when I say contract increase, what I'm actually saying is read from the channel increase forever.
Yeah.
And match according to the argument list I give you, which is ACK in this case.
Okay, that makes sense.
So a contract is nothing more than a persistent read. And
Syntactic sugar.
it's syntactic sugar, yeah. So perhaps it might be more appropriate to write it in using the syntax in line 8 because that's more sensible. Read from that channel forever. But line 9 basically says read from this channel forever. That's what line 9 says. So it binds to the channel that you sent to counterfactory, the Rholang code specified after the equal sign on line 9.
So it's basically this is exactly equivalent to this.
It is exactly equivalent, yes.
Okay.
I think that is really helpful. Thank you, Bill. And I think just as a general point, that's kind of how I'm thinking of Rholang now. It's going to take ages at the amount of time I spend on it each week. But essentially, if you keep unpacking it into the basic constructs, everything makes sense.
Yeah, so I mean, it's always about what is the channel, who's writing and who's reading. It's always about that. Yeah.
Yeah, but the syntactic sugar is useful because if and when we're developing bigger programs, you want to be able to think in terms of functions and parameters, and the syntactic sugar lends itself to that sort of thinking. Am I right?
Well, yes. So, the fact that a mathematical construct, like the row calculus, the fact that the mathematical construct works doesn't mean it can be comprehended by every human being on the planet. And so we create syntax for that.
Question: when you write to ACK, where does this go?
So ACK goes back to the channel provided on line 9. So increase is a channel that receives another channel. Jim, am I correct in this?
Increase is an unforgeable name. Okay, and we're sending to it
An ACK channel.
an ACK channel.
An ACK channel. Right.
Yeah, but what if you send something on that ACK channel?
Well, that's what line 13 does, right?
Where does it go?
Well, it goes back to whoever sent the ACK to us.
No one did though. If line 8 is correct, then I think Kirill has a valid question, right? Because it's almost like the ACK channel only exists for the duration of the for comprehension.
So the ACK name associated with the channel, the ACK name associated with the channel only exists inside of the for comprehension or the contract.
So what's the point then of sending the?
So the channel always exists, but the name we give it only exists inside the contract. So down here on line 34, I send it X.
Yeah, we send it X and we
Okay, I send it X. X always exists. It's a channel.
Yeah.
Okay, but the name X will only exist inside the new that is used on line 29. After the new goes out of scope, the name goes out of scope, but the channel still exists. It can still be written to as long as you have a name for it.
My increase.
So what you're saying is the channel.
The channel is persistent. The channel is immutable.
Yeah.
It exists in the blockchain. It exists in the tuple space. It exists. The only reason you can't use it anymore is because you don't have a name for it.
So is the ACK we're using within the contract the same ACK as we're declaring on line 29?
Right. So let's go up and look at increase. So on line 9 there, or line 8, depending.
Yeah.
What you're actually doing is just giving the channel a new name called ACK. It now has 2 names. It has ACK within this scope. It has X within the other scope. So it has 2 names, but the channel is still the channel.
Now we're getting to something I've not understood before about how Rholang syntax works, because I didn't realize the sense in which, excuse me, the sense in which ACK and X are the same thing as a channel. So
They are exactly the same thing. Yes, they are exactly the same thing.
And that then tells me that another error I'd made was to assume that channels and names were the same thing, which they cannot be, because
No, so I mean, and I don't want to take this analogy too far, but if you think about pointers in C,
yeah,
I have a block of memory somewhere.
yeah, exactly.
And it exists, and I can have multiple pointers to that same memory.
Yeah, I think you say you don't want to take it too far, Bill. Is that not exactly right in terms of the implementation?
Yeah, so I mean, what I want to avoid is using other languages to explain Rholang, because Rholang is a different beast. But
yeah.
But if you think about it in terms of what a compiler would do to the variable names in a C program, these are just names. ACK and X are just names. They're just names for channels.
Or just pointers to addresses. I'm sorry to be explicit.
Yeah. In a sense, they're just pointers to addresses. Yes.
So you can think of it.
They're references.
Yes, exactly. So we can come back in a second to the nature of Rholang, but just to move away from it for a moment and understand the implementation within our chain. Essentially, ACK and X in this case are the names of pointers which reference the same address, and the channel is the address.
Yeah. So on line 13, we are writing to the ACK channel, right? Which we now understand is actually the X channel, right?
Yeah.
What happens if we were to read from the ACK channel? We are allowed to do that. It's just a channel. And if somewhere else somebody wrote to the X channel, we would read it here on line 13.
Yeah. So now well, first of all, we should check. That was really useful for me. Kirill and David, did you get that?
Yeah.
I assume David did as well. It's not said otherwise. So
Well,
now,
we should say welcome to Precious. Precious, did you get that?
Yeah, I think is he still there? I can't see him.
Yeah, he's still here.
Hi, Precious.
Oh,
So does that make sense? I mean, this is just giving a channel a different name. So
It does, Bill. Could I ask another question though, if no one
Sure.
else has got any? So thank you for that. That was really useful. But now if we take a step back, so it was really useful for me to relate names and channels to pointers and addresses. But in doing so, we've dropped into implementation details. And as you rightly said, if you want to view this stuff through a different prism, namely the prism of just Rholang and Rho calculus and processes running in parallel, if you're looking at it through that prism, then you almost want to forget about the implementation specifics of pointers and addresses. Is there another way of describing the difference between a name and a channel or not?
So let me try a different analogy. Let's talk about sockets.
Okay.
So I may have a socket, and it has a port number. It's got some other attributes that go with it, and a socket is essentially a way to communicate, right?
Yeah.
I can read from a socket, I can write to a socket, right?
Yeah.
So if we imagine channels or sockets, I can have more than one process, more than one thread, more than one stream of execution reading against my socket.
Yeah.
And I can have more than one thing writing things to that socket from the other side, right?
Yeah.
What happens when I read a socket and there's no data there to read?
You wait.
If it's in blocking mode, it blocks.
Okay.
And a for comprehension is a blocking read.
What do you mean by block? Sorry, Kirill's probably with you. I'm a bit lost.
Meaning if there's no data there to read, it waits.
Okay, yeah.
Okay, so line 8 literally means sit on this, using this other terminology, sit on the socket increase and wait for something to come in. When something comes in, put it in ACK and process it.
When you see the word for, say what, wait for.
Wait for, right.
That's useful.
Wait for, yes. Wait for ACK to come in from increase and process ACK in whatever's inside the braces.
What's the difference between a persistent read and one?
So a non-persistent read, so if I change the equals to a dash, it means do this once.
So it would still wait until it's done it once, but once it's done once, it's done.
Right.
What does that mean?
So what that means, so let's look at line 10, okay? Line 10 says, wait for a value from current count to end up in old.
Yeah.
When that happens, do the things inside the braces and just go on and do whatever you do. If I change that to an equals, then every single time something gets written to the current count channel, line 10 will execute. Which is obviously not what we want because we actually want to store a value in current count, right?
Yeah.
So if you look at line 12, if I change the dash to an equals in line 10, then line 12 would write something to current count and line 10 would go, hey, something was written to current count. I need to do this.
You'd have an infinite loop, would you?
And you'd have an infinite loop, yes.
Question.
Sure.
So if you've got two for comprehensions reading from the same channel, is that possible?
It's completely possible, and the results are non-deterministic because everything happens in parallel.
Yeah.
But yes, you can have multiple reads on a single channel. The results are non-deterministic. Jim, am I correct about that?
You're correct, absolutely. And you can in essence, use it as a queue if you want, where anybody can send a value to it, and it's just first come, first served, whatever. You get a result.
So one of the very common programming patterns in client server stuff, again, going back to the socket analogy, is I have one socket, I spin up a piss load of threads that are all sitting on that socket, right? And then I spin up a piss load of clients that are going to send things to that socket. This is non-deterministic as to which thread receives what client message. And typically inside such a server, all of those threads would be running the same code. Nevertheless, we don't know which thread gets what data.
Right. Like, when we call increase, we don't know which increase is done first.
Right.
Yeah.
Right. And that's actually an important point, line 34 and 35. Line 34 and 35, we don't know if 34 gets executed before 35. We just don't know. We know that one of them does eventually get executed first, and then the other one. And so on 37, we don't know if B comes in before A or A comes in before B. We just know that they both have to come in order for us to do line 38.
Yeah.
Is all this making sense, Rich, Precious, David?
So actually, if you run it multiple times.
Yeah, in theory, you should get different results.
In answer to your question, Bill,
I can't see the results. Oh, now you can.
So you got increase 1, increase 0. If you run it again, you might get increase 0, increase 1.
Yeah.
So that non-determinism is what allows for the great concurrency and parallelism that is Rholang. And there's actually significant work that you have to go through to make sure that things get executed in a serialized manner.
I sort of have a question around that. Maybe
Sure.
if we scroll back to the code, just because sometimes I think it helps to see the code on screen when we're talking. Thanks, Kirill. So, and I'm not going to be specific on the code here. So I would say, in terms of what I'm calling the implementation, I believe, perhaps incorrectly, but I do believe I understood everything that you just discussed in the last 10 minutes, Bill. So thank you for that. However, I've got a niggling problem with the term that Rholang runs in parallel, given that every time we describe what's happened, we ultimately end up talking about the implementation, and that things don't happen in parallel, they happen in an indeterminate sequence, hence the indeterminism of the result. Whereas my understanding of Rholang calculus is that it should literally execute everything in parallel, which on today's machines we can't implement. And I'm wondering.
So in the mathematical realm, everything executes in parallel because it's theoretical. In the real world, we do have to deal with the fact that there is resource allocation that takes a varying amount of time, depending on the state of the state machine we're operating in. So if I change the state of the computer acts differently.
Exactly.
So the absolute parallelism that the Rholang calculus affords is only really exists within the math world, because we do have to run on state machines. And so unless we know the exact state of the state machine before we run our Rholang calculus, we cannot determine the outcome.
And I follow and agree with all of that.
Right.
I guess what I'm realizing is, and it pains me to say it, what I don't really understand is the mathematical theoretical world, which is a bit I like to think I do understand, in that what should happen if everything progresses in parallel. How do you get to the next state? It's almost like a SQL query, right? you can do funny things with SQL, and everything happens at once. And the SQL engine makes sure that that really does work that way.
Yeah, it does all the joins and everything for you, does some optimization according to its rules, and then it gives you back a result.
Yeah, and I'm trying to remember but it's something like, if you take column A and add it to column B, and then so you do something like select A plus 1, select B equals, column B equals A plus 1, and A was initially 1, then it would basically all at the same time, it would increase the value in column A from 1 to 2, and then in column B it would return 2 plus 1 is 3, which is very counterintuitive to procedural programmers. But in that sense, all the operations happened in parallel. And I foresaw the Rholang calculus, if implemented on a state machine, should act in the same way. And yet on the implementation of Rholang we've got here, that is not happening.
Well, no, it wouldn't. It wouldn't, because a database has a file system, and that file system is like a buffer. So you have a transaction for the database. You have a transaction, right? And you have these commits. So typically, when you execute a set of transactions, they're either committed to the file system, or if the power goes down, they're not committed. So the transaction never happened.
Yes, so it's all or nothing in the progression of state. Yeah.
Here, it's all about updates to the network.
Well, and I want to point out that, and this is why making comparisons to other languages can be problematic.
Yeah.
You have to realize that in the select statement that you proposed, Rich, that there are things that are known. Okay, there are variables that you're working with, right? So and the database parser and optimizer knows that.
Yeah.
In Rholang, everything is a channel, and you never know the state.
Yeah.
Whereas in the select statement that you were talking about for a database, the state can be deduced. In Rholang, the state can never be deduced.
What's deduced?
Because everything's a channel. Jim, am I correct? You're on mute if you're talking.
The state of the Rholang machine is a tuple space.
Right, and the tuple space cannot be deduced. Does that make sense, Rich?
It doesn't make sense to me.
No, I would say it is an advancement in my ability to evolve my working model, which is incorrect. And therefore, I think it was a worthwhile 5-10 minutes. But I would agree with Kirill that no, it doesn't make sense in itself. I think the gist of what you were getting at, Bill, I would say, yes, I hear you. I hear what you're saying. Because I've heard Greg say, it's almost like I know I don't get, if you look in the mathematical realm, I know I don't get yet the pi calculus and the rho calculus, but I see it almost as an evolving system of sends, if you like, things being passed around a system without ever landing and getting state. And I think that's what you're referring to. But certainly in the implementation, I would lean to agree with what Jim said, which is there is a state, and it's the state of the tuple space.
Yes, yeah. So what Jim said is correct. The tuple space is the state that of relevance. What I want to emphasize is that tuple space cannot be deduced. It can only be produced.
Yeah. And why can't it be deduced? Because you've not got a global view of the whole code that's executing. Is that why?
Right.
Yeah. So now I think I could say that I understand. So if you were sort of omnipotent, some sort of god of Rholang, you could see everything that was executing, and therefore you would know the state.
You would know the state, and in theory, you could perform optimizations.
Yeah, but in reality, you only ever know the execution state of things you've already found out, and they are limited by the scope of the code you can see, which is a subset of the total code, and therefore you cannot know the total state, because something somewhere else might have a pointer to one of your channels and might overwrite it with something. And so you can never.
So the pi calculus, and I'm getting a little out of my depth here. So Jim, correct me if I get any of this wrong. But the pi calculus defines a set of rules that can be performed. It does not define what the outcome is. The only thing it defines is an end state, meaning that the pi calculus construction comes to an end, so that there's a terminating condition, or there is a production of something else to which a pi calculus rule can be applied.
Yes.
That is the only thing the pi calculus defines.
Yeah, and the only terminating state in the pi calculus, to my knowledge, is the nil process.
Is the nil, right? And the roll calculus proceeds according to similar ideas.
Yeah.
That there is a terminating state when you get to nil, but you cannot deduce the next state based on the state you're in, because it hasn't been produced yet by the rule that you are applying.
When you say deduce, what do you mean?
It's not predictable. We know that in the row calculus, the rule that is applied will produce something to which another row calculus rule can be applied. We know that. Okay. But what we don't know is what rule will be applied next, whether or not it's nil, which is a terminating condition. So the number of steps it takes to get to nil is not deducible, because we don't know what we're going to get next. We just know that a row calculus rule outputs something to which a row calculus rule can be applied. That is all we know. We cannot predict what it is. We can't predict how many rules have to be applied to get to nil. We can't predict it. We just don't know. And so while the tuple space is the state of the R node machine, we cannot predict the next tuple space state given the current one. We can't do it.
Why not?
Because we actually have to run the Rholang in order to find out what the next state is.
Yeah, but when you receive comments,
I understand your confusion. I really do. I get confused at times with this myself. But the rules of the roll calculus are such that they do not produce a predictable state.
Okay.
The rules of the Rholang calculus are you send things on a channel and you read things on a channel.
I think we might be onto something with the notion I mentioned of it depends how much of the code. No, you're right, but yeah, you're right, Bill, because
So again, let's go back to the code real quick in the development interface. Again, let's look at I guess it was line 17. No, I'm sorry, line 10. That's a for comprehension. Okay. That says read it once. If we change the dash to an equals, we don't have a predictable outcome.
why?
Because it becomes recursive.
This is really deep. I'm liking this, even though I'm not understanding properly.
So what I'm trying to say is one of the rules in Rholang is I can read from a channel. That's one of the rules,
Yeah.
right? And then there's a persistent read on a channel. That's it. There's maybe a more advanced rule, maybe.
Yeah.
All we know after, so on line 9, we're saying, I'm going to read from increase that channel forever. That's what I'm going to do on line 9.
Yeah.
When I get something in ACK, I'm going to run the Rholang from 10 to 14. That's what I'm going to do.
Yeah.
And what I'm guaranteed of is that line 10 will produce something that can be passed through a Rholang rule. Line 11 will produce something that will pass through a Rholang rule line, and so on and so on and so on. I'm guaranteed that the application of a Rholang rule will produce something that can be processed by a Rholang rule. That is all I'm guaranteed of. But the Rholang rules themselves do not guarantee outcome. They just guarantee that whatever they produce can be processed by another rule.
How do they not guarantee outcome?
And that's where I'm out of my depth. Now you're really big into the math of it, okay? I'm sorry I can't take you down that path, but the reason that Rholang can be as general as it is, that everything's a channel, is because the rules are general, and that's where that's the limit of my knowledge.
Fair enough. Thank you.
So you can go have a conversation with Greg, maybe. I don't know. Tomislav. You could read the Rho calculus, I suppose, and find out why.
I think there's something in my statement about it depends on the scope of the code you can see.
Right. So I mean,
almost like information theory is coming into this. Like,
yeah. So one of the things we constantly have to deal with in Rholang when we write it is the scoping operator, which is in this case the braces.
yeah,
Right. So you just don't know what's going on inside another scope. These are called namespaces, right?
Exactly. And if you haven't got access to namespaces,
You just don't know, right? You just don't know.
If you haven't got access to namespaces with whom you share channels, then that, I believe, is potentially where the
That makes anything that happens in your local scope non-deterministic. That's what that does.
Exactly. Whereas,
Okay. So
am I right?
So now if you expand this out, So now if you expand this out, so Kirill is running an R node on his local machine, right? And that R node has a tuple space. That's what it has. It has a tuple space. Now, if Kirill was actually running a blockchain, there would be other R nodes and they would have their own tuple spaces. They would have these same channels. They'd be doing these same things, possibly, or might be doing something else. And the outcome of the Rho calculus calculation is indeterminate.
It's impossible for any local operator to deduce the outcome.
Well, and if you think about it, let's talk about mainnet or testnet, right? It's a real big blockchain, right? Running tons of nodes, and it has all these tuple spaces inside these individual nodes. If you were God and could look at the entire blockchain and condense all the tuple spaces, then you could know what's going to happen.
Exactly.
But the whole point of the blockchain is you don't know what's going to happen. The blockchain takes care of itself.
Yeah.
And Rholang is a language that gives you that in these local scopes as well.
I'm going to have to think on it more, but that was.
Jim, am I right?
I believe enlightening.
I hope what I've had to say has been helpful.
Yeah, the overall thing is that you're saying when I receive this pattern on this channel, do this. When I receive that on channel, do this. So you have all these rules and you don't know which one's going to be done first. They're all in parallel. So you can't say which one's going to be done next, and that could change the outcome. If things are called in a different order. But
that's a very nice way of putting it, Jim.
Right.
It makes perfect sense in what we're observing when we run Rholang code. My question to you, Jim, would be, do those statements also apply to the mathematical realm of the Rho calculus?
Well, necessarily so.
Well, would it as the Rho calculus, as the operations take place, is the mathematical essence of a process reducing, two COM events come together in the Rho calculus, or two processes, they combine and reduce and produce a new process. That is how the Rho calculus processes.
Yeah, so within the math realm, you have the absolute theoretical parallelism, right?
Yeah.
So yes, there is no order within the theoretical realm of the math.
But so I guess that's what I'm saying. So if lines 33 to 35, to bring it back and make it concrete, but pretend we're talking math, not code. So forget everything we know. If we've got 3 pars there and 3 processes within each par, my previous understanding was that with the maths that all 3 would somehow execute at the same time. Whereas now I'm questioning whether that interpretation is correct.
So let me make the following statement and see if this helps. Line 33, 34, and 35 are deterministic, but not predictable.
Yeah, it does help. What we have to remember is
we know that what comes out of 33, 34, and 35 is line 32, bang, gets written to result, and we call my increase twice. We know, deterministically, we know that that's what happens.
Yeah.
However, it is not predictable.
I think I've just got it. what we have to remember is that this is if we were talking maths, this would represent a term in the, it would represent an item, a process, if you like, and
Yes.
it would combine with another process, and we don't know what that other process is. And when those two processes combine, the output would be a third process that is simpler, because that by definition is what the maths does. And,
Yes.
and the way in which it's indeterminate is we don't know what we're going to receive to combine with.
Right. So we know we know that this is deterministic, but we also know that this is not predictable.
And that's why.
And that's why you can get different answers from Rholang code depending on how many times you run it. We know that the outcome of the entire thing is deterministic.
But
We cannot predict, but we cannot predict how it does it.
Yeah.
But it's not deterministic. It's we either get 0 first or we get 1 first.
No, that makes it unpredictable. As a collection, the lines of code are deterministic. But not predictable.
Okay, yes.
Well, the state in that now we're with Jim's comment, we're back to the implementation, aren't we?
Yeah.
And it depends almost on the state of the underlying computer or state machine,
Which cannot be known and cannot be deduced because of scoping problems.
So basically, they're continually searching for reads that match writes.
Exactly.
And depending upon which one they hit first, when you have a bunch of stuff in para, depends on I guess the order they're in your tuple space, which
Well, we could probably drill down much further and say, you know, it depends on whether or not the randomness of the Turing machine that it's running on is sufficiently random. You know, I mean, we can drill down as far as we can go with this, right?
Yeah.
So the simple fact of the matter is that the state of the machine cannot be deduced. And so the code is necessarily unpredictable, even though it's deterministic.
And I think that statement, even though we don't fully understand it, probably applies to both the implementation, where we can clearly see it as we run the code, and to the maths. But whether or not the implementation and the maths are exactly consistent with each other, I don't know, and it is a concern because, of course, there should be.
Well, I mean, the maths, you know, with sufficient elbow grease and brain power, can all be collected up and combined and sufficiently reduced to a minimal program, right?
Yeah.
Okay, but that's you know, I mean, that's in our heads. That's not real. The fact that it still works, you know, on a real system is what makes Rholang useful.
Agreed. Is it time to get back to the code?
I thought Carol was in charge, so lead the way, Carol.
I mean, I could talk about this all day, but I think that was really useful, Bill, and I need to go away and think about it. I'm not sure I personally am going to get much further.
Yeah, I mean, you've reached the limits of my knowledge. So, I would encourage you to reach out to the people who understand more the mathematical underpinnings of this. So maybe that's Greg, maybe that's Tomislav.
Yeah.
There are other people who understand the maths behind this better than I do.
Thanks for your help, though. That was very useful. Okay.
The last Casper stand-up was about, what was it about? It was about
CBC Casper. It was about correct by construction and proving it in a mathematical model.
Yeah. So you can look at that.
I would actually encourage you, Rich, to go out and take a look at that. We had a meeting with Greg last Thursday where he started to run through the mathematical modeling behind the correct by construction for block merge.
Biologic, please.
Yeah, I'd love to, Bill. My problem's lack of time. Unfortunately, I've got a living to learn processing boring SQL. But,
I gave that up in order to do this full time because this is a lot more fun.
I don't disagree with you at all. Fortunately, I quite like my house as well. It's been a toss up at times, I'll be honest, but yeah, I do like having a roof over my head as well. But as soon as I get some chance, definitely. I think for me, step one is going through the rest of these tutorials that we've already covered and mastering, the implementation side of things. And then step two is to get onto the maths that you've just talked about. And as I did a maths degree, I'm probably quite well placed to do that. But
well, then you and I should hang out more often because I don't have a maths degree, and you might be able to explain some things to me.
But yeah, just lack of time, mate. It could be a year and a half. I'm happy to have a conversation with you, a scheduled conversation with you sometime, and see if I can help. But I'm pretty certain Greg and Tomislav will be more help than I could be. Anyway, moving on.
So if we could, Carol, can we go back and talk about the equivalence between the persistent read and the contract syntax? Let's just go through that again before we move forward.
Yeah.
So what we're saying is that line 8, which is a persistent forever read on the channel increase, that is identical to line 9. Line 9 literally means read from the increase channel forever, looking for ACK. That is what line 9 means. And I realize that, in terms of human being and syntax and whatnot, it doesn't really read that way. But you need to remember that line 9 is equivalent to line 8.
Yeah, so far so good.
Rich, does that make sense? David, Precious, does that make sense?
It does to me, though I would comment I was surprised that it's a persistent read.
Well, it has to be. It's a contract.
Yeah, I understand what you're telling us. I just, that to me suggests that whenever anybody writes to the channel increase, it'll immediately get read into
Yes.
the channel ACK.
That's exactly what that means. Yeah, that's exactly what.
That's the only reason you would ever send a message to increase is to increase the counter.
Yeah.
So part of, I think, the cognitive problems here are that line 9 looks like a function definition and line 8 doesn't.
It's almost like an interface. I mean, that's what a contract's supposed to be, right?
Well, I don't know. But line 9 and line 8 are identical. Line 9 looks like a function. Line 8 does not.
Agreed.
And I think for people who have worked in other languages, that can be that can be confusing.
I'm much more comfortable, bizarrely perhaps, with line 8 than I am line 9.
Yeah, I think I like, if I were to do this contract counterfactory, I think I would prefer line 8 over line 9 as well.
Damned if you do, damned if you don't.
Yeah.
But you know, the persistent reads can be easy to overlook, but that may be because we don't use them.
No,
But, you know,
I agree with you, Jim. If you gave me, that's why I said the moment you get to lots of code, it's quite nice having these contracts lying around, especially if you know and get in the habit every time you see contract channel name of function value to in your head convert it because it
you know, it's a capability, a persistent capability.
exactly, you're right, and using the contract syntax tells us that we're talking about a capability, whereas the for comprehension construct can be used in lots of different ways semantically.
Well, and this is a little off topic, but in our chain token, which is the big work that Raphael is doing, he actually mixes the two syntaxes. There are some contracts and there are some persistent reads, persistent fors.
In order to make the code easier to read by any chance, or
well, yeah, I think it is. You know, I mean, it's just the way he thinks. It's just the way he thinks about things, right? And so whatever makes sense to him, since it's his baby. So, but there is a mix of these things. But yeah, I think yeah, anytime you see the word contract, think of it as a persistent read.
And in a different context, think of it as a behavior that can be used.
Well, so the difference between line 8 and line 9 is I can now take the name increase and send it somewhere. Right? So if I'm creating a new name inside counterfactory, so I mean, line 9, obviously that's not a new name. Increase is not a new name, it's defined on line 2. But if I'm creating a new name, I can now take that name and throw it on a channel to someone so that they can receive it. Whereas a persistent read on line 8, I can't necessarily do that.
When you said the words throw it on a channel, what do you mean? Or perhaps in order to answer that, how do you mean? How would you do that?
Carol, if you would please, in action in that box there, select, what are we looking for? Let's look at new inbox. Okay. So if you scroll down, please. Okay. Line 18. Literally what that does is it takes a name of a contract, it reads it from the lookup channel, and it puts it in the name get me. So get me now refers to the same thing that other thing refers to. And this is the way we pass around capabilities in Argo. Line 20 uses that capability to create yourself an inbox. So there's a file out there that, you know, someday we'll look at that defines a contract, and it has a name, right? But basically it's just a persistent read, but it gives it a name at the same time as it makes it a persistent read. And that name can be returned when you look it up on line 17. Does that make sense?
Say again?
So on line 18, what we're actually receiving is a contract. We're receiving a persistent read. And we're putting that into the name get me. On line 18.
That's not a persistent read though, is it?
That is not a persistent read. What we're doing is we're reading from lookup channel, whatever happens to be there. And what happens to be there is a persistent read.
Now I understand. Because the process within the name, if you dequote lookup channel, star lookup channel, you get a process. And what you're saying is, you know that the process that is contained within that lookup channel is a persistent read.
Is a persistent read, yes. And now I'm going to give that persistent read a name. That name that I'm going to call in this scope is in this scope. That name is get me.
Yeah.
And so now I have a persistent read that I happen to call get me.
So it's like you've copied a process.
That's right. And so on line 20, I'm actually sending something to that persistent read.
Wow. Not me. Yeah.
And that persistent read will receive what I sent it. It'll return something to me on ret. And on line 21, I read that. This is what Jim and everybody else refers to as capabilities. So the get me persistent read that's referred to here is actually a contract that I wrote to create yourself an inbox. And someday we'll go look at that code.
I saw it. It's what? Sorry, go on. So David or Precious?
I don't think it was either one of them. They are on mute.
Okay. In that case, I would comment, say thank you, but what you've just described there is the essence of the row calculus, really, and yes. by association, therefore, Rholang, and it very much, whilst looking at code, got the closest I've ever got to the idea that the row calculus can pass code around, or pass capabilities around, or because processes do not have to be literal values like strings or integers. They can be more code.
Well, of course they can. Rholang is a reflective language.
That's the definition of reflective as well, is it?
In my mind, it is. If I'm able, if I'm able to pass code as a variable to something, now I have the essence of what's called a lambda, right? And now I can apply the entire Lambda Calculus.
I don't quite get that.
Neither do I.
So a lambda in other languages, let's talk about, let's think about C again. If everybody understands C well enough, let's say I create a function and I give it a name, right? And it does a thing and it returns a value. And now let's say I create another function, and that function is supposed to iterate over a list. Okay. And I give that iteration function a pointer to another function and say to it, and so what it's supposed to do is go for everything in the list, for every item in the list, apply the function I just gave you. In C, these are called function pointers, right?
Yeah. Yeah.
Okay. So the function that I am sending to the iterator is called a lambda. And there's serious math called the Lambda Calculus, which describes how lambdas work. But basically, it's the idea that you're passing an operation to another operation. That's the Lambda Calculus.
Yeah.
And if you ask me more questions, I'm going to have to tell you I'm at the limits of my knowledge at that point.
No. This is brilliant, Bill, because you're tying a lot of terminology together. And even if it's not 100% correct, you're broadly, I think, correct.
So yes. So the row calculus is a superset of the lambda calculus. I can send to a channel code. I can send it a lambda if I want.
Can I ask one other question about reflection?
Sure.
And it's a curveball in a way, but the only time I've come across the terminology of reflection is where you look up the type of something you don't know. So can you describe that process of saying what type am I as passing code in some way? Or can you comment on what I just said?
So type doesn't really exist in Rholang. Everything in Rholang is a channel.
Mm-hmm.
So there's no such thing as type.
Yeah.
So the closest you can get to type in Rholang is the use of a match. So if you look at line 21 on the screen right now,
Yeah.
that's a for comprehension. And what it says is read from ret anything that happens to match a tuple of two things, the first of which is a thing that we're going to call success. The second thing in that tuple needs to be another tuple that contains two things claimed in my stuff.
Yeah.
That's a match. That's the closest you get to typing in Rholang.
Yeah.
So we could also match against a map or a list. We could match against a set. That's the closest you're going to get to typing in Rholang. And it's actually one of the things that Jim and I, it's actually one of the things that Jim and I have been working on, is how to introduce typing into Rholang, similar to the way TypeScript puts typing into JavaScript.
Fascinating. And you know what? I think what you just described is very close to actually answering my question, because I think you could continue to say that identifying what type you are is executing code against something that you want to match against in order to return true of this type.
Right. So one of the things that I hate about C, one of the things I like about C++, and one of the things I like about Rholang is, in theory, you never really need to type the keyword if. That correct by construction means you don't need alternation.
What does that mean? Alternation?
The alternation is basically or.
Condition.
You don't need conditionals, right? That correct by construction means you don't need conditionals.
To which Kirill's question still stands. Why?
Because while under the hood, in our brains, we understand that line 21 here means if what comes out of ret matches this, then do that, otherwise do nothing. That while in our brains we can process what line 21 in that sense, that's not actually what a match does. Mathematically, a match is not alternation. It's not if then. It's not condition.
It's declarative, right?
Yes, it's correct by construction.
Boom. I'm loving this session because I'm loving the way all these difficult terms are starting to fit together and make. I won't go as far as perfect sense, but I will. Perfect sense. Yeah. Thanks.
Well, like I said, if you want more, I mean, we're getting to the limits of my theoretical understanding. I mean, for the most part, I'm a practitioner.
Pretty deep and pretty advanced here, right?
Yeah. For the most part, I'm a practitioner. So, you know, some of the theory questions are just completely beyond me. So,
do you write Scala?
I do not write Scala. I've been told that I should learn it so that I could help out the core team, but I'm busy trying to do other things, so I don't have time.
That's a big problem, isn't it? But collectively, I think we can get there, even within this group. So
No,
within
I love the fact that you guys can learn. I mean, there are people that I try to talk to about these things, and they're like, "What?"
Well, it's hard. In fairness, it's hard, right? So this is non-trivial.
Well,
anyways,
it's certainly a different way of thinking.
Yeah, exactly. What's hard, what's easy.
In any sense, I hope I understand. I explained the answer to your question by showing you line 21 here, right?
You did. I'm going to endeavour, Bill, to go on mute for the rest of the session so that Kirill can get back to the tutorials and we can get some work done. But thank you for answering my long-winded questions.
I hope I was helpful.
Very, very, for me at any rate.
All right, Kirill, lead us down the path of no return.
Okay, method dispatching. Yeah, this is how to reset the counter, I guess. Reset ACK. We can replace ACK with a nil process, I guess. Oh, excuse me. Right. There are two primary techniques for making methods available. The first option I call separation of powers, because each method listens on its own dedicated channel. Each method listens on its own dedicated channel. Yeah.
What he's calling method here, if you look at the block of black, you have two quote unquote methods, method 1 and method 2.
Yeah.
Okay, now as we understand now, those aren't actually methods. Those are persistent reads on a name called method 1 and a name called method 2.
Yeah, we talked about this.
Right. So that's one way to do it.
Another option is the control panel technique, where there is a single unforgeable name called the control panel, and all the methods are built onto it, on it.
And that's the second form.
Panel. It's control panel. Right, and yeah, this composes a name.
Right, it takes the list cPanel and method 1 and turns it into a name, and the same thing with cPanel and method 2. creates names out of those. Hold on a second, guys. My wife is in need of me for a second.
Which technique did the counter example use to dispatch methods? So there's separation of powers. Listens on its own dedicated channel. I think it's the separation of powers. Which technique did the counter example use to dispatch methods? It's the separation of powers.
Right.
Methods available. The first option of separation of powers, because each method listens on its own dedicated channel. Another option is the control panel technique, where there is a single unforgeable name called the control panel, and all methods are built on it. So what's the difference? So the first one has contracts inside a contract, and the other one has a contract, and inside you have two contracts that are actually names. There's not much of a difference between both of them. I think the second one is more clear, or is it? No, it's not necessarily.
Right now, it's 1 second.
What the second one affords you, that the first one does not, is that if you keep a reference to cPanel, you can invoke method 1 and method 2 simply knowing the strings method 1 and method 2.
Yeah, but why would you use that if you can use that?
Well, the thing is, if you have, let's say you have 100 methods in the class, then you would have to have 100 unforgeable names. And you'd have to keep 100 different unforgeable names. If there's only 2, there's really no advantage, since managing 2 names is not much of a problem. But if you have 100 methods, or you want to be able to add more methods later.
Okay, so it's this is a regular function, and this is sort of like an object capability.
Yeah, well,
Yeah, so that terminology is going to twist Jim around.
yeah, that's.
So look at separation of powers in the black box, and with, like Jim said, let's say that you have 100 capabilities. So you have method 1, method 2, method 3, all the way up to method 99, method 100. How many arguments does the factory contract need to receive?
One.
Well, it needs to receive 100.
Oh, wait. Factory contract.
Under separation of powers.
Yeah. Those are a lot of arguments.
That's a lot of arguments. And not only that, whoever is invoking factory would have to have 100 channels declared, 100 names, one for each of these methods. That's a lot of names. It's a lot to manage. It's a lot to maintain.
Understood, yeah.
So control panel pattern means that I need exactly one name for cPanel. And as long as I remember that and the strings that I need, then I have access to those methods.
Yeah, it's a little bit confusing. Normally you would, call it by the name of the object, right? Where cPanel doesn't say what kind of object it is. But instead of saying cPanel, we could say, put in any object type there. Could be a calendar. So we could say a factory for a calendar has contracts for today, appointment, whatever functions a calendar had. And so you would only have the one name for the calendar, and we would put that in a list here. It's put in a list. It could be put in I don't know if you could. I think it could be put in a tuple. Could be put in a could be put in a set or a map.
Okay.
Whatever, but you're creating a name. You're creating a name from a process, and by including in that process the unforgeable name as a where we're making the whole thing is unforgeable because we can't forge one of the one part of it.
Okay. So should we go to object capabilities? Are you Rich? Are you okay with that?
I am.
Right. Well, finally here.
So now we get to the hard bit.
We made it.
So this is the hard stuff.
Okay, let's see.
That's simple.
Recently, we've learned how unforgeable names can restrict the use of a channel to those who know the name. Recently, we learned how unforgeable names can restrict the use of a channel to those who know the name.
A few weeks ago, we did that, I believe, when we got into deployer IDs and things like that. We talked quite considerably.
Well, and this also goes back to what we were talking about earlier this session, where ACK and X were both names for the same channel.
Yes.
That's
So unforgeable names
right.
resolves that problem if you use them. Yeah, you can stop other people getting access to your names.
Right.
In all probability.
Right. Nobody has access to my channel unless I give them a name for it. They can't forge an unforgeable name for my channel. That's what this says.
We've also see how state channel, this is incorrect. We also see how state channels can be used to store data, and methods can be used to modify encapsulated data. We also see how state channels can be used to store data.
I think that's correct, actually, Kirill. Do you remember state channels are just the use of Rholang to write some data to a channel and then pick it up again?
No, the sentence is incorrect.
Oh.
This we've also see. It's incorrect.
You are right. The English is wrong. Yeah, we also see. Yeah, not we've also see.
We also see how state channels can be used to store data, and methods can be used to modify encapsulated data. In
Yeah.
this, you will see how methods that are placed on unforgeable names leads to a tremendously useful design pattern known as object capabilities. Wait, wasn't that the control panel pattern? An everyday example of an object capability is the key to your home or car.
I think two things, Kirill. Firstly, yes, I think you were right in what you said, and secondly, it's we'll also see, not we, isn't it?
It should be seen, not see. Right. We can
Is it
fix that.
past tense though, or is it talking about the future, Jim? We will also see.
We've also seen how state channels can be used. We have seen.
Yes, I think the N is missing. Yes, I agree.
So, so at the bottom of the page, you can click edit this page. And you can fix it.
Fixing it.
Well, whilst Kirill's getting there, can I just ask, have we seen how methods can modify encapsulated data?
We saw that in the counter factory.
Right.
Where there were two quote unquote methods,
Yeah.
increase and reset.
But was the data encapsulated, i.e. private?
The data encapsulated was the counter.
Right. The only way you can access the counter is through those two methods.
Thank you for the explanation, Jim. And you're right, Bill. Yeah. Okay. So yes, and we have seen that. You're right. Thanks.
Yeah. So information hiding actually exists. I mean, they're calling it encapsulation here. Perhaps that's not the best term, but information hiding actually exists because a channel doesn't have to be exposed to you in order for you to do things with it.
Indeed. Which is object capabilities.
Right.
All right.
With objects, you can also have the ability to delegate by giving to key or a copy of the key to someone else. What?
Right. He's calling a capability a key, which, you know, a capability is just a name that's being read by something.
This lesson will build up a few example projects that uses state channels and object capabilities. We'll see that object capabilities can be used more generally than bundles to grant permissions such as reading and writing data, but also more abstract capabilities like resting a counter or deleting a Facebook account.
So it's resetting a counter or deleting a Facebook account. And I think what we're talking about here really is that reading and writing are very specific capabilities, whereas we can pass general code around through these object capabilities and do more general things like those two examples.
Let's revisit the air traffic control from lesson 4. Previously, controllers were able to broadcast weather and runway information by using a repeated send, but they were not able to update the information. And we all know weather can change unpredictably. So in this example, we'll store the current information on a state channel and give the controllers capability to update it as necessary. Right.
So it's important that we don't give them access to the current message directly. They only get they get 3 capabilities back. So there's no way they can set the current info without calling set info. And there's no way they can read the channel in a non-persistent way and wipe out the values. The only thing they can do is get and set. So we're restricting the capabilities of the channel current message.
Right. Previously, controllers were able to test weather and runway information by using a repeated send, but they were not able to update the information. And we all know weather can change unpredictably. So in this example, we'll store information on state channel and give the controllers a capability to update it as necessary.
You know, this is, simply mutable state.
So this is where the weather's stored station factory. So station factory is defined here. And it has these methods defined. Initial message, get info, set info. Airport info.
Hey, check. Nicotine. I'm smoking like a smokestack.
Huh.
So if you using the okay, when he for each station, he's going to call the station factory to make a new station, and the 2 capabilities is going to get back the set info and the get info. Okay, now the get info. Oh.
Weather's nice.
Something's wrong here. Get info.
No, I think there's nothing wrong here.
Oh.
Well, it's not wrong, but for the get info, he could have done a peek instead of reading and writing it back again.
Yeah, but I believe that that this allows for older versions of Rholang where peak wasn't implemented.
Yeah, well, I don't think we have anything written in old language anymore. We certainly don't want to teach people to do it the old way. but this indeed works.
So current message. Current message is weather's nice.
Right.
No,
And
yeah, the weather's nice. And it's received by both get and set.
what?
No, it is referenced in both get and set.
Station
When-
factor.
When you call station factory with a bang, what it does is it creates a new channel that locally is known as current message. And it gives it sends to that channel an initial message. It then creates a persistent read on set info and a persistent read on get info. When you call station factory, that is all it does.
Set info and get info.
So it creates the two contracts and it creates a channel that contains the initial message. That's all it does.
Okay. So, yeah. And we need to send airport info. After the station has been initialized, or we can send to the other capabilities with those channels. Okay. Yeah. It's the same pattern.
Yes, it is the same pattern.
I get it.
This is information hiding. In this case, what we're hiding is the weather info, is the current message. We're hiding that data.
I get it. It's really cool, especially if you were to use that in a web interface, like to set something on an object, like a post, a blog post, or a form of some sort, right?
And yes, and importantly, I mean, the reason that the object capabilities section is important, if you scroll up, please. Let's say I didn't put set info in here.
So,
All right. That means that the capability, the object capability of setting the information doesn't exist for you. You can't do anything with the data, current message, because it's hidden inside the contract station factory.
yeah.
You can't touch it. You can only do the things that I allow you to do within the definition of contract station factory. And so I have complete control over what you're able to do to the data that I've hidden.
I get it.
That's what's important here.
When you say I have control, you mean whatever's set on whatever code runs under station factory, set get info, an initial message.
That's all you can do.
That's all you can do. Yeah.
That's all you can do.
When he says you have control, I think he means the author of station factory has control. Is that correct, Bill?
Yeah. So I can write a contract station factory. Yes, Rich, you are correct. If I'm the author of station factory, I get to determine what you are allowed to do with current message. Current message is in my scope. It's hidden from you. And I can provide you capabilities to do things with it, but you can't do anything with it that I haven't provided to you.
So who am I and who's the author?
So the author is me. I wrote Station Factory, and you are the test case down below, new airport info.
Okay. Yeah. No. I could 100% get it.
Okay, so the important thing to understand here is that the author of the smart contract, which is Station Factory, the author gets to decide what users of the smart contract are allowed to do. That's the important thing to understand.
I get
And
it.
and the things that the users of the smart contract are allowed to do are called object capabilities.
So those are like public methods.
Yes, but I'm going to encourage you to not use that terminology.
I understand why.
Because some object capabilities, as you progress in Rholang, there are some object capabilities which are considered public and some which are not. The English understanding of public, private, and protected, as we understand it from C++, are given new meanings in Rholang.
I understand.
Okay.
And you have Unix and Unix-like operating systems.
Right.
And there's a difference, obviously, in implementation, but it's similar. Let's say it's similar.
And I will agree. Yes, it is similar to what you describe as public methods. Yes, but you need to be careful.
Could I ask a couple of questions on that?
I thought you were going to go on mute.
I will. Okay.
No, please ask your question.
Believe it or not, this was me trying to. You probably can believe it. This is me trying to go on mute. So, how exactly do object capabilities match to passing processes around? Are they the same thing?
Well, let's go look at the code for Station Factory.
Mm-hmm.
So set info is a name, right? If I take that name and I turn it into a process, I can now send it anywhere I want.
Yes.
Does that answer your question?
Forgotten my question now.
So I can take set, I can take.
It does. The answer is they are exactly the same thing.
Right. So if I want to enable someone else to use my set info capability, which I got from calling Station Factory, I turn it into a process, I give it to them by sending it to one of their names. And now they have access to my set info capability. So they're going to have it under a different name than I have it, but they still have access. That's why we call it an object capability, is I can pass it around. I give you the capability, or Carol the capability to do what I would do if I call set info. I give you those capabilities, and now you can do that.
And the terminology object capability is nice though, because you can sort of look at this contract Station Factory and say that's the object and it's capabilities of this object that you've defined.
Right. So now let's consider let's step out one level here in terms of Rholang abstraction. Let's say that there's so I'm in the weather tower at an airport, and so I get a Station Factory, right? Well, I can employ the same pattern that's used in Station Factory to hide my Station Factory. I can get back my set info and my get info capabilities, but if the weatherman at the local television station wants to update my weather, I can give him my set info capability And now the guy at the local TV station can set the weather on my behalf because I have given him my capability. He can't access Station Factory, but he can set the information.
Is there a subtlety in what you've just said, Bill, which is that Rholang allows you to give specific names or people?
I can share with you whatever capabilities I have.
Whereas the public-private thing is a bit more global, isn't it?
Yes. So if I'm the weather guy at the airport, I would create a Station Factory for the weather. And I would give to the airplanes the get info capability. I would not give them the set info capability because airplanes should not be setting the weather. But I can give them the get info so that they can get it. And then I can give the set info capability to the local TV station, and I can let the weatherman at the local TV station set the weather. So now as this all evolves, the airplanes are getting the weather information that the guy at the local TV station set. The airplanes can't set it, and the local TV station can't get it because I haven't given them those capabilities. This is the notion of an object capability, that people only get what I give them.
Beautiful.
Does that make sense? Does that make sense, Kira?
Yes, it does.
Okay, so I would imagine, I haven't seen this tutorial before, but I would imagine they're going to go through something similar as we scroll down.
It may seem natural to use read-only bundle for tuning into the station. However, if we use a bundle, then the first listener to receive the message would consume it from the state channel. It wouldn't be left for other pilots to receive. In order to ensure that the message is persisted like we want, we handle all access to the state channel ourselves and only give the pilots a capability to query for the correct message. Okay.
Where in this code did we give the capability to individuals as opposed to everybody, or did we not?
Nowhere in this code are the capabilities distributed.
Okay.
So the call to Station Factory there that we see on the screen, weather is nice. What we get back is an airport info, which is the get.
On the set.
And we get back a set, which is a set. We haven't given anybody the airport info or the set capability yet. We could give other people that, and I would imagine later in this tutorial they'll show you.
I'm with you, I think. Yeah. Yeah, so it's in the external code that the author does the giving.
Nobody has access to it except me unless I give them access to it. And so I should probably keep a list of like all the airplanes and give them the get capability, right? Something like that.
Yeah.
Exercise, write more tests, thorough tests to make sure the air traffic control can update the status successfully and that pilots cannot. How do we do that?
Well, that's exactly the example that I was portraying to you. So we would have to figure that out.
So would we have to write it, create some pilots, create some local weathermen, give them?
Yes,
Yeah,
yes. The answer is yes.
that might be a problem for another day. It's 9:40 here. I'm happy to get to the bottom of the, do you want to do it now, Kirill?
Preferably not. But
Shall we use that as a revision of where we've got to next week?
Anytime I show up on these channels, I always wear out Kirill. He always gets tired by the end of it.
Well, if it's any consolation, the reason I wasn't on video was I was lying on my bed. I was so knackered, and I felt that might have looked rude. So you tie me out as well, Bill. But it's always a pleasure.
No, and I understand it's a bit later by you guys too. So.
Yeah, I think I'm done this week. But Jim and Bill, thank you very much for your help, and Kirill for driving.
yeah, I'm going to go as well. It's been a long day, to be honest.
It's been a brilliant session, though. Thank
Yeah.
you, thank you. Is Jim gone?
Jim is probably taking care of some kind of dinner for himself, I would imagine.
That's more than reasonable. 17th, he said, so I should see him next week, hopefully, to wish him luck. I'm going to drop then, guys, because I'm pretty tired and I've still a bit of work to do. So, but once again, thank you.
Thank you for your time, Rich. It's good to know that you're learning.
Yeah, definitely learning. Much appreciated.
Thanks, Rich. Bye.
Cheers, man.
I guess Jim's walking Felix.
He might be taking Felix for a walk. He might also be cooking dinner. He might also be smoking a cigarette. It's hard to say.
Yeah. Okay, I'm going to go as well.
Yeah, Jim is back.
Hi, Jim.
I don't think he can hear us. He certainly can't talk to us because he's on mute. There he is.
Now I can hear you. So
Jim, we were about to call it a wrap.
Yeah.
all right. So,
Ciao for now, Kirill. Play around with this and we'll see what you come up with.
Thank you for everything. And yeah, see you next week.
All right. Ciao for now.
good.
Would you stop the recording, please, Jim? Jim? Can you stop the recording, please? Jim, can you hear me?